An AI that works through hard math and coding problems, step by step, just ran on a Mac Mini. A San Francisco startup called DeepGrove built it, named it Maple Preview, and this week put the whole model out in the open, free to download and run. Powerful AI usually runs in a data center, a rented GPU, and a monthly bill. Maple Preview does that on your own machine. It is a reasoning model, the kind that works a math or coding problem through step by step, and it deploys in about 5 gigabytes, small enough for a Mac Mini. The model is open, free to download and run. It is a preview, built to reason. DeepGrove says it is weak at using tools on its own, a math and code reasoner, not a general assistant. A 20 billion parameter model should not fit on a laptop. A model stores what it knows in its weights, billions of numbers it tunes as it learns. DeepGrove trained Maple's weights to be one of just 3 values: -1, 0, or +1. That is ternary, and the keyword is train. Most small models are built full size, then squeezed down, and that costs accuracy. DeepGrove built Maple ternary from the start. Normally, one weight is a 16-bit number, 16 ones and zeros of storage. A ternary weight needs about 1.5 bits. So a 20 billion weight model that fills about 40 gigabytes at full size packs into about 8 times smaller. It also changes the math. The core operation is multiplying a weight by a number, billions of times per word. When the weight is just -1, 0, or +1, that multiply becomes subtract, skip, or add. Exactly what small chips like a Mac Mini or a phone are fastest at. But 20 billion weights is still a lot to run per word, so 2 more tricks help. Maple splits into 256 small expert networks, each a specialist, and only 8 wake up per word, so only about 1.5 billion of the 20 billion run at any step. And it barely rereads itself. A model keeps a growing pile of notes on what it has read, and rechecking all of it is slow. Most of Maple's layers look only at the last 500 words, so that memory stays small even as the text grows. After all that shrinking, does it still reason? On DeepGrove's own tests of competition math, competitive coding, and graduate-level science, Maple averages 78.7, topping every model in their comparison but one, a bigger Quen model, at 82.9. These are DeepGrove's own numbers, no outside test yet. The clear gap is graduate science, where it scores 73.5, behind a smaller full-size model. Near the top for its weight class, not the top score. Here's the whole point in one chart: reasoning quality against speed on a Mac Mini. The models that reason about, as well as Maple, sit slow, near 13 words a second for ternary bonsai 27B, and 47 words a second for GPT-OSS 20B. Maple sits far to the right, about 170 words a second at that quality. DeepGrove calls that 5 to 16 times faster than efficient models like Gemma 4 and GPT-OSS, with a lighter, slightly less accurate setting they call Flash, reaching about 220 words a second, all DeepGrove's own on-device measurements. You can get it today. The weights are on Hugging Face, free and ungated, under a plain MIT license, so anyone can download, run, and build on it. The fast 5 gigabyte path uses the small Apple Silicon runtime DeepGrove chips. The desktop GPU code is a separate, heavier route. The link is on screen. Reasoning models have always lived in data centers. Maple fits a 20 billion parameter, 1 into about 5 gigabytes on a Mac Mini, because its weights were trained to just -1, 0, or +1. The real story is not a leaderboard. A data center class reasoner can now sit on your desk.